All right, welcome back to week 26 of Hobby Kernel Development. I have a singular focus today, which is to fix this bug. So when I run my kernel, I am getting all these reboots. It's just rebooting all the time because I have problems with my virtual memory, probably. And so that's what I'm going to try to do today. Actually, do I have my Miro just in case it's needed? All right, bring that over just in case we might need this. Yeah, just for context, I'm working through this MIT operating systems course, and I have been working through lab 3 exercise 2, parsing and loading an ELF binary image. And apparently I kind of suck at that because something is going horribly wrong. And let's figure out why. I'm coming into this kind of cold today, so I'll need a couple moments to really get back into things. If I recall correctly, one of the last things I did last time on week 25 is fix this bug where I was actually computing the program headers incorrectly. And I fixed it by doing the pointer arithmetic and then the cast to program header. So this is going to be a debugging stream. I'm not really going to probably write that much code today, but I'm going to attempt to systematically debug a triple fault, which I've kind of been learning how to do over the last couple weeks because I've been doing that a lot. But let's just, let's take a look. So, So just to kind of get some context also, so I'm working on this function called load icode, which is responsible for taking an ELF binary and loading it into memory within the context of this environment, which is basically a process. And actually, right now I have a panic in the function, and so ordinarily it should actually panic. Like the kernel, we should expect to just run it, and then it hits this panic 333, which would mean things are good. But it doesn't do that, and something in here is wrong, and is triggering problems with the virtual memory, which are causing page faults or exceptions, which I don't handle because I don't have any handling of exceptions or interrupts yet, which results in a double fault, then a triple fault, then a machine reboot, which just comes back into this. The client code of load icode is this check load icode function. So I actually am pretty confident that it is this specific call site. So this function check load icode is kind of like a poor man's unit test for the function, and I'm just kind of invoking it in different ways. So one thing just to kind of level set a little bit is I'm just going to do a panic 99 and just run that. Do we see a panic 99? We do see a panic 99. Okay, that just anchors us a little bit in terms of what is going on. And so everything's fine up until here. And then we call load icode, and we actually pass in this ELF binary. It's a really simple user space program. And then that's when the bug happens. Yeah, maybe I will update my top text real quick. debug elf loader. Okay. Yeah. So now we've been anchored. I can get rid of that. And now it's time to kind of figure out what is actually going on right here. And so I'm going to insert, basically the way I kind of approach this is I'm just going to gradually insert more and more panics until it doesn't reboot anymore. So I'm predicting that this should not panic. It did not panic. And let's just see. So now I can start to check if these program headers look correct. I have my read elf output here in this bottom pane. And so we can actually look at the program headers and what they are supposed to be, and then verify that against what we're parsing out. File size. I wonder does that work? That's cool. So file size, mem size. Yeah, I guess I'll just do kind of all of it. Vadder. Does that work? That's cool. Hope that works. VA. Offset. Set. Does that work? Yep. Good. Let's just give this a try. Like nice and easy. So that all worked. And let's examine. Let's just take a look. This is the first program header. Offset 1,000. Vadder 200,000. File size 12. Mem size 12. So good news. I think we are finally parsing program headers correctly, which is good news. And so now I hit this panic. So now time to basically just kind of like binary search it a little bit. I'm just going to move it all the way down here. What about now? That panicked too. So that means we fully executed this first part of the code correctly. And just to refresh on what this code is actually doing, the core idea is that this program header represents data that needs to be copied into the process's address space. Okay. First thing we need to do is allocate memory within the process to store the data. And so that's where we get our region alloc that takes in a user space process environment. It takes in a destination virtual address, and it takes in a size. And so just Vadder comes basically just from this P virtual address thing, which is how the segment advertises what virtual address it needs to be at. So we just use that. And the mem size is the other thing, and that advertises how much space in memory this thing needs to take up. And then because region alloc will internally round up to a page size boundary, it will return to us the actual full amount of memory that it's allocated, which would be actually pretty interesting to print. Okay, so now And I guess just real quick, I kind of forget region alloc. Does it return error? It doesn't error. Huh. Yeah, it panics if it cannot allocate anything, which is good because it's easier for us as a client. It's also not good because that doesn't feel like good API design, but whatever. So now we've allocated memory. Now time to mem copy into that memory. So we have our mem copy with the destination, source, and length. So destination is going to be destination vouter. Yeah, that should totally work. The source, interesting, comes from binary plus offset. I think that should be right. Binary is uint pointer, and so all the pointer arithmetic is going to be very natural. And I kind of, yeah, this is the part where I guess a little bit, but I think that's correct. It might be helpful to have more of the ELF documentation around. Maybe I'll just quickly do man elf. Man elf, it's funny. Okay, I am curious. This offset thing, there's all these offsets. Just checking on the, okay, it's still recording. This member holds the offset from the beginning of the file at which the first byte of the segment resides. So I think this is correct. And then there's the file size. Holds the number of bytes in the file image of the segment. Right, so we copy in the file size from the ELF file into memory. And then lastly, we want to memset and zero out the rest of the allocated memory that we haven't written to yet. So I compute, and maybe this is possibly where some of my bugs are. But so basically it goes back to this visual that I made, where my understanding so far is that there's this, there's like the segment, which is like this part, and partially it has some file size, we copy in the data, partially it has this mem size, which we zero out, and then also partially it has this alignment component, which we also need to zero out. So my kind of understanding so far has been that we need to compute this starting point of the point to zero out, and then zero it out. And maybe I'm getting the math wrong, but I kind of thought it would just be like this plus file size. So say file size is like 4 bytes. If you add 4, is there an off by 1 error somewhere? I don't think so. If you just add the number of bytes, then you have that many bytes before, and then your pointer begins kind of at the end of those after that. So I feel like that's correct. And then I'm computing some distance, which is basically the mapped length, which is the end, minus the file size, which I kind of was hoping that would be right. I thought that would produce this length. So that's an overview of what the code is so far. And it didn't panic this time. So now this is actually a little bit more complex to debug. So now it panics, or sorry, it doesn't reboot this time. So now I need to do something like if I is greater than 0, panic. So now I want to let it run through the first time, and then kind of on the second time, I want to panic and do my, similar thing. One second, my phone just buzzed, so I'm gonna check that. Nice, okay. Yeah, let's do this. So now basically this is like the second time through. So the first time it's gonna be 0, so it's not gonna trigger this. On the second time, I wonder, we should only have 3 iterations of this loop. Okay, yeah, so even on the second iteration, it starts to fail. So we're making some progress. So now we can bump this up. And I'm just gonna bump it up to the top, do a typical, okay, so typical kind of like binary searching through stuff. I'm gonna move it down here. What about now? And that works. So that kind of is consistent with my understanding. So now we get to the juicy part. Is it the mem copy? Is that what's doing it? Okay, that's not what was doing it. So basically that leaves us with only one other possibility, which is that this mem set down here is the one that is causing the reboots. And it's time to figure out why. So let's take a look back here. Does it look parsed correctly? Mem size, file size F10, vadder 800,020. Yep, offset. Okay, yep, 1020, yep. And then, okay, I mean, those are the main ones. Maybe I should be respecting this alignment, but I'm totally ignoring that, actually. Right, and so interestingly, we have our mapped len print now. And this is based on the file size. And so, you know what, I bet I have an off by 1 error somewhere. Yeah, I bet, okay, I don't really know what's going on, but I am forming an immediate intuitive theory that my mem set is like writing off the end a little bit and writing into unmapped memory. That's my theory so far. But let's test, we can test that. But just to observe that, map 1000. So mem size in both cases is less than hex 1000. And so it's expected that we're going to round it up to the nearest page, which is 1000. So that's expected. So now we can maybe do some experiments to see. And so this is going to reboot. Good. Okay, first off, if we just don't mem set, that's not going to reboot. Right. If we reduce the mem set by like 100 or something like that, let's check that out. It doesn't reboot. So that's starting to support my theory. What about -1? Is that an off by 1 error? No? Okay. Just blindly guessing a little bit. Right. So interesting. So going back to the visual, yeah, so my goal here is just to zero out this whole region. And to be more specific, we can actually put in some numbers here. So in this case, the mem size is F10. That is so small. Wow. Okay. Mem size is F10. The file size is also F10. So these are, okay. So in this specific example, oops, it looks more like this. Mem size and file size are both F10. Okay, 20-second break. Be right back. Right, okay, so that's like kind of nice because it's a bit of a simpler case, I guess. And map11 is still a hex 1000. So this is what it looks like. And let's go back to the code. I'm just going to shit. Does this work? Okay. I will move the panic up. So does this make sense? So Viator, interesting. So Viator is not page aligned, which, yeah. And so yeah, but so maybe the issue is with the region alloc. Maybe I'm allocating it incorrectly. But it looks kind of correct to me that 800,000, 20 plus F10, 800, F30. So now what I want to do is start just doing some little pokes into memory at specific places to more precisely understand exactly which addresses are working or not working. Yeah. I'm curious if region alloc, So region alloc is designed to be able to handle, maybe I have a bug here. Fine. Interesting. I suspect I have a bug here. when VA is not. So yeah, I already was trying to handle if VA is not page line, and I rounded down. I think I need to visualize this. So let's say this is a page. And let's say vAdder is not aligned onto that. So in this case, it's like it's this hex 20 offset from the start of a page. And the size is only F10. And so it's still less than a page. So this is like the start, and let's say this is the end, something like that. So this is the approximate range. Yeah, okay. I think something is definitely kind of wrong here. Okay, I'm going to split this and come back to here. Right, so memstart vAdder is this thing basically, and it should just go to the end of the page. That is my expectation. And I'm just going to print this as hex. Does that look right? So mapped length. Okay, no, I think I have an issue. That didn't immediately seem right to me. So hex 1000. I have like hex 20. And then it's like F30 or something like this. Okay, yeah. I kind of have a guess now. So, this is the start. And then the file and mem size, yeah. But I am subtracting like so F10, right? It's like about here or something like that. So there's hex F10. And that is the file and mem size from the alignment point. And I'm computing this distance from the end to just the plain mem size. But then I'm computing the start pointer over here, and then mem copying that same distance, but from a point that is further on because of the lack of alignment. And then I'm going off the end. Okay. Pretty confident that's the issue. So the way I need to do this, so I need to basically take alignment into account. And instead of computing the difference between the mapped len and the mem size, which is not adjusted for alignment, I should actually compute it relative to this endpoint of this mem start vadder thing. That's it. I'm pretty confident that's it. I don't think this is actually going to work because it's a pointer, which is so annoying. So I could cast it. So depressing to do that. And I kind of never know which one to use, but in general, when in doubt, I cast pointers to u into pointer t. Mapped len is an int, though, unfortunately, so now I'm mixing my signs, which, but wait, this is wrong. Like this is, okay, that's wrong because memset start vadder is a pointer, and mapped len is just like a length. So I basically need to take the pointer, I could technically compute 2 pointers. I could really compute like an end pointer. Yeah. I can compute like a full end pointer and then subtract the memstart vadder pointer. Maybe that's kind of nice and easier to do. And so simply end pointer. All these names are so bad, but it's going to be somewhere that's like the end pointer. And I would be surprised if this compiled because I'm doing arithmetic on void pointers now. I don't think it will compile. It compiled and ran. What? Okay. So end pointer, and then it's going to be, yeah, end pointer. I don't know, do I need this anymore? And that worked. I think that did it. It would be cool to go into the debugger and really verify everything, I think. But man, wow, this alignment stuff is pretty tricky, actually. Yeah. Yeah, that was an easy mistake to make. So now I'm really just computing this end pointer and this end pointer and using this distance between them rather than incorrectly computing the distance from the mem size to the end. So that's buggy. I wonder if I get rid of this, will it hit the 333 panic? I hope so. No, it didn't. Ouch. Okay. Oh wait, but I'm stupid. Okay, so now but it didn't actually, I didn't actually test it. So does it hit this? Okay, no, I didn't fix the bug. That didn't work. But I think I'm onto something. I think I'm close to it. It's also kind of dangerous, I think, to be doing this subtraction and then passing it into memset as a length parameter, which I think is unsigned. Yeah, that's a recipe for some really bad overflows in case that's ever negative, which it shouldn't be, but okay, so I fixed nothing, but I am kind of learning. So I'm just going to move back this up so I can read some of these prints. And something is still not right. Why? Okay, no, I'm computing the end pointer poorly. Okay. Okay, so end pointer is, it's actually the dest v adder rounded down plus the mapped length. It would be pretty nice if region alloc would just return some of that info back so we don't need to recompute it. I can pass a struct back. It's kind of annoying. Well, for the moment, I can just kind of hack it just to make progress on the bug. But yeah, end pointer is wrong. Yeah. Oops. Test the adder. Page size. Does this compile? It compiles. This looks better. So now end pointer looks right. So this is the v adder rounded down to 800,000 plus 1,000 of the mapped len to yield a nice clean 81,000 as the end pointer, the first out of bounds address. And then we have memset start v adder, which is the v adder. We also, oh yeah, we need to zero out the space before too. Okay, I am incurring so much pain right now from this alignment stuff because I am kind of optimizing a little bit prematurely. And I mean, yeah, the actual simplest, correctest thing to do here is just simply zero out the entire allocation that we just get from region alloc, or maybe even tell region alloc to do this. And then we can just write in some stuff on top of it. But that's wasteful and inefficient because what if you actually need to write data into like the entire region, then you spend all this time zeroing it out and then you go back and then memcopy it back over that, which is wasteful, but it's way easier to be correct and avoid bugs. And instead I'm trying to be optimized and whatever, and copy in the data and then kind of surgically memset the other regions around it, so that every byte in the region is written to exactly once. And this is causing me pain, basically. So what my visual doesn't really represent is alignment well. So let's say it's more like this. The vert adder is here. And so this also needs to be zeroed, which is very annoying. Okay. Yeah, interesting. I will intentionally not do that and observe it in the, well, I don't know if there's going to be much to observe in the debugger. One thing that could be pretty interesting is like a debug feature where the allocations are kind of poisoned with a certain hex byte. I might even just do this for fun. So region alloc, 20-second break. Yeah, I also need to watch the time today. I need to leave a bit earlier. What would be the easiest way to poison the, so this is where it happens, page insert. The interesting thing is I don't actually check return code. This can actually fail. And I just totally, okay. Check. I'm not gonna do that now. Or am I, should I just do that now? Okay, if ret less than 0, nick. Failed. Okay. Okay. Not accumulating technical debt. So so let's say page insert succeeds. All it does, it just operates on one page at a time. And so, so I'm just going to add a debugging feature, mem set at dest va, which should immediately be available for use. And what character hex 42? That I kind of forgot how to do that and then page size. It's not really poisoning, but it's just poisoning the allocation. That's kind of fun. I've never done that before. Okay, so now I'm going to the end data 0 out the before data makes me do this. Okay, that's a to do for later. I'm not going to do that for now, so I can observe the poisoned memory Yeah. But now, wait, am I good? Like, can I just run this? So now, it's, yeah. Endpoint is right, memset start veditor is right. And if I, D0, is that right? But we're operating in base 16, so 3 minus 16 is 13, and I guess that's D. A, B, C, D, 10, 11, 12, 13. Yeah, I think that's correct. So, moment of truth. I'm gonna move this down, and we'll see if we panic. I hope we don't panic. Oh, we do. I mean, we don't panic, but what? That's so disappointing. Huh. Oh, maybe. No, actually, that was different. That's from the memset here, actually. I suspect. I think that was buggy what I did with the poisoning. Yeah. Okay. So. Is it because it's. Maybe there. Maybe. Oh, I see. Yeah. No. Well, okay. I don't know. For some reason, this was actually buggy. Even though it's always making them writable. Okay, whatever. That's annoying. Is that the issue? Does this? No. Something is messed up. Okay, I have no idea what I'm doing, apparently. I thought that would be legit to do that. Oh, that's why, because I'm inserting into the page directory of the environment, but I'm not actually switched into it. So what I would need to do is quickly, temporarily switch it in and switch out, which is kind of cool. That's like some pretty kernel hacker type shit to be doing. I need to quickly switch in to the page directory, write the memset, switch back out. I think that'll work, actually. Nope. But it's panic. It's like rebooting in a different place. It's actually getting to the elf loader. Like it wasn't doing that last time. Okay, I don't know what I'm doing. That's broken. Oh, actually no. I see the problem. Interesting. It's not always appropriate to hard code switching back. Oh man, because in load icode, I'm intentionally trying to be within this page directory. Man. Okay. I want to poison this thing though, but it's proving to be so inconvenient. I guess basically to do this properly, I should read CR3. RCR3, is that a thing? Yeah, I should read CR3. This will be pretty cool. 2t CR3 equals read CR3. And then get the initial one, save it, and then bring it back. I actually wonder if this will work. I would feel so elite if that worked. I think that worked. Nice. So now we're trying to poison the allocation. This function is called from various contexts. Sometimes it's called from the kernel context in the kernel pagedir. Sometimes it's called within load icode, where it's intentionally trying to be within the environment's pagedir. And so we definitely want to switch in to the environment pagedir to do the memory write. But we need to know kind of where to return back to. And so we can't hard code that destination. We need to actually just kind of generically look it up by reading it and then switching back to it. So now the poisoning should actually have worked. And also what is kind of awesome is that now if I really get rid of that, we should see the panic 333. That I really hope we see. We see it. Okay, awesome, amazing. And one of the last things I'll do today is jump into the debugger and observe the poisoning, which will be very exciting. Oh man, okay. Yeah. I wonder how I could just do load icode. That's the first one, that's the garbage. Now we're in the second one. And time to step through. So this is the first segment, which is not interesting because it's page aligned. Now we're on to the second segment, which is the interesting one because it's not page aligned. It's like the hex 20. It has the hex 20 offset. So, region alloc. That just worked. So let's just take a moment to, I think, does this work? Okay, I kind of don't. Right, did I just type it wrong? Oh, I'm messing up. There we go. There's the poisoning in full effect. This whole page is poisoned, exactly like I wanted it to be, even from the start. Hex 800,000. So notably, if we drop it down one, go to it would be 7FFFF, I think. It's not even mapped. So, right. And if we go all the way up to the top of the page, we can see that it's poisoned right up to the next page. So that shows that the poisoning is working perfectly, which is great. So here's what we're going to see. So I currently, I fixed the bug in my code, which was responsible for doing the reboots. And so now it zeroes out the end part appropriately, but I've intentionally not fixed the bug where I don't zero out the start, just so we can observe it with the poisoning. This will be good. So we've seen that the whole page is poisoned. And now time to copy in the data and do the mem set. And now let's go back and take a look. So that region is no longer poisoned. It's perfectly cleared to 0 all the way to the end. And the start area, though, has what? 32 bytes or 16 bytes or whatever it is. I think 32 bytes of 42s because we forgot to clear that out, which is pretty satisfying to see. The reason I needed to poison it is because the memory probably would have just been zeros anyway. And so it would have not been observable whether it was intentionally overwritten to be 0, or the memory was just naturally 0 and we got lucky with it continuing to be 0. So as a last thing I will do today, I'll fix that part. It's very annoying. Yeah. And then do this. Okay, quick check. Does the program still work? Okay, wait, compile. I made some. Okay, yeah. Does the program still work? Yes. And now memset dest rounded down to 0, and it's going to be dest vadder minus dest vadder rounded down. Put some dangerous to do pointer arithmetic, which might result in signed int. Okay, question, does this work? Yes, and as the last thing we'll do today, we'll jump back into the debugger and verify that those bytes are now poisoned. So this is the garbage binaries now are going into the real one. I'm gonna step through. This is the first program header. First, yeah, loadable segment, not interesting. Not interesting. FEE, it's an interesting one. Now we're in the interesting one. We region alloc, and we dump vadder and observe. Yeah. Observe that it's poisoned all the way from the start of the page. We then go mem copy the binary in, mem set the initial region, mem set the end region, bam. And let's take a look. And look at that. Some nice clean zeros all the way in the beginning. So that looks pretty good to me. So what happened here? So basically I had the bug. I had 2 bugs. One caused reboots. The second one, which I just fixed, would not have caused reboots. It would have just been silently a security issue in the kernel, because it would have been uninitialized data that would have been loaded and visible to user space. So that would have been an info leak security issue. And for example, if you're a security researcher, you might have used that kind of bug to leak pointers out of the kernel, or leak information about kernel data structures, or leak information from other processes running on the system, or what have you. But we fixed it, so that's good. The second bug was related to clearing out the memory on the end of the segment, and I was computing the math incorrectly for that. And yeah, okay, just to end things, let's just watch this one more time. Bam. panic 33. So that means we successfully reached like basically the end of the main elf loading code. And with that, I'm going to bring the stream to an end. Thank you very much for watching. I have a Discord. Like, comment, and subscribe if you like what I'm up to. And I'll see you next time. Peace.